Last page is on probability, which matches up with Unit 10. For this page, we're using the scenario at the top here with 20 pieces of candy for all of the problems. The first one's just asking for the basic probability of choosing a red piece of candy. So there are 11 reds out of 20 total, and if we could, we'd reduce, but in this case, that does not go down any further. Like I said earlier, we're going to skip over B. We didn't do odds. For letter C, we want the probability that it is orange or yellow. So in this case, this is an addition because or would imply either one will work. So there's 6 orange candies plus 3 yellow candies for a total of 9 out of 20. We don't add the denominators. We only have to add the numerator since they're common. And again, 9 over 20 also does not reduce. Letter D says that we want to pick 4 red candies in a row without replacement. So that means, first of all, that we're not putting them back. So things are going to change as we create our second, third, and fourth fractions. Also, this is an and because we're drawing them in repetition, in succession. So we don't want or this one or that one. We want red and red and red and red. So the first draw, there's 11 out of 20 reds in the bag. Times the second draw, there's now only 10 reds, and we also have to subtract off the bottom, so there's only 19 candies total. And so we'll keep this pattern going, so the top will subtract and the bottom will subtract for each one. And then that ginormous fraction multiplies, if you just multiply across, we get 7920 over 116,280. And if you reduce it all down, fractionally, we get 22 out of 323. If you were to change that to a decimal, you'd get something like 0.6 or 0.068, which is about 6.8%, just to refresh your memory on changing the format as well. And then letter E is asking us the probability of choosing a red candy. This time we're replacing it, and then we want to choose an orange. So again, probability of red, we've seen this one now 3 times. That's 11 out of 20. It is an and, so we are going to multiply. And the orange candies, there's 6 of those. That's unaffected no matter what we do with the red piece. But in this case, since we are putting the red candy back, there's still 20 in the bag. And if we multiply those together, we multiply across, so we get 66 out of 400, which reduces down to 33 out of 200. And then lastly, question F is one of the probability problems with variables. It reads a little bit differently. This time we know that we're going to choose a red candy, not put it back, and then choose some other candy. We don't know the color, but we do know that the probability is 33 out of 190. Our question this time is to find the color of the second candy. So yet again, probability of red, that's the first draw, is 11 out of 20. The second time, though, we don't know the color, so we're going to call that X. And we're not putting it back, so that means there's only 19 candies for the second draw. And we know that the probability of all that is equal to 33 over 190. So first thing we'll do is multiply the leftmost 2 fractions together. So 11x over, that gives us a 380 in the bottom. And then we want to cross multiply so we can solve the equation. So we'll take 11x times 190. That gives us 2090x. And we'll take 380 times 33. That gets us 12,540. And then we'll simply divide both sides by 2090. And we get that x equals 6. And if we look back up at the top, there were 11 red, 6 orange, and 3 yellow. So that means the second candy was, oops, we missed candy. The second candy was orange because there were 6 originally in the bin.